So an update into checking the ER-40 collet holder. Pretty much I'm confident that everything I did was reasonably accurate as far as my test results go. Measurement wise, that's a bit different kettle of fish, but I'm sure there's run out on my collet holder and my collets. However, one comment I need to address, and that was I correctly torquing a cap nut for the collet holder? And the answer to that question is no, I was not. And the information that I've been given and I've checked, and they are absolutely correct, is 130 pound-feet. Now, that's a fairly high torque for putting on a milling machine, but that is the torque that it is, so I'm going to test that theory. And you never know, it might turn out that it does actually pull the collet up tight enough to straighten up. But we're going to find out. So I'm going to rig it up again. I've got the spindle free to rotate on its own, so there's no pressure with the belt, anything like that. So the point of this video really is to check the run out of a hand tightened collet and the correctly torqued collet and see if there is any marked difference between the two. So the only thing I'm really going to redo from the last video is actually check the run out of the collet holder. The mill should be the same as it was before. So it's all clean, wiped off, everything's nice and tidy. So it's deviating 0.1, 2, yes, 3. Yes, that's 0.103 of a millimetre. Now, personally, that is horrendous. Now I can't remember what that figure was that I gave in the last video, but that's what I'm getting there. 0.103. Let's see if I can get it further up in the holder and see what that looks like. What have we got there? That's 0.09. The deflection. So this is one of the collets that I've used previously, and as such I've got it marked with an alignment mark, which on here is there. And there's the writing. So first of all, let's do it up to the torque I was doing them up, which really wasn't a huge amount, I must admit. Right, so let's see what we are getting with that. Right, so we're getting 0.1 0.1, 0.14. 0.14 of a deflection then. So before I turn it round, so there's no arguments, I'm now going to torque this up to the correct torque. So you saw me make this in a previous video, as well as this, all now brightly lovely painted, because when you left it, or when I left the video, it was just a bit rusty metal. So it's all nicely painted now, and it's all, yeah, okay, so only painted spanner, whatever. Anyway, so got this converted 3/8 drive, 3/8 drive ratchet, length for this, calculation, pounds feet, drops from, I can't remember what it was now, 170 something Newton meters, which is 130 pound feet, and that with the conversion length of this, 114 Newton meters, which was 84 pounds feet. So 84 pounds feet set on the dial. Let's get the Spaniana on. Torque wrench. Bloody hell. That is frigging tight. So let's see what we got. Well, hasn't made that much difference. It has made a difference. I'll grant you that. It has made a difference. We have got, what's that, 0.11. So, what I'm going to do is going to undo this at the expense of a lot of energy, and then I'm going to rotate it 180 degrees, do it back up again. Right, where's my lettering? My mark. So we want to mark about there. Right, again, I'm just going to do it up with the tool I normally use. And we will have a look. Point 1.11. So 180 degrees out, the figure is the same as it was when I torqued it right up. And let's test again. If anything, it's made it worse. .2 rather than 1.1. So I was planning on doing a test with just a little 1/4 mil, but I think exerting 130 pounds-feet of pressure up on this is overkill for this collet, especially since half the collet is not used. So what are you doing to this part of the collet compared with this part of the collet? This part of the collet is fine, it's compressing directly onto that component, but this part, it's got nothing to compress against, so I don't like the idea of that. So I'm not going to test this one. Instead, I'm just going to move straight on to this. The last collet was a 19mm collet, 19. So we're looking at 25mm collet, an inch. It's an inch bit. And as before, I've made sure that my part is all the way up to the top. Now, have I marked this one before? Yes, I have, I think. Yes, I have. So I've marked this one, so this is one of the ones I've tested before, I think. Admittedly, I don't think I use this end mill, but... Right, start at the beginning. Find your mark. There it is. To make that easier to see, I think I'll just put a pen mark on there. Just so I know. Okay, so let's set that. And let's wind that back in. Let's try again. Point 1, 1. Yes, 0.115. Let's talk her up. .112. So it made it worse by 0.005. Before I totally cool this, I'm going to slacken this one off, rotate it 180 degrees and just do a recheck. But this seems to be, every time I torque it up, it seems to make it marginally worse. .1 .35. Yeah, 0.135 run out. So it's worse than it was on the other side. So let's torque a right up, see what happens. One, four. So I've made it again 0.005 worse, which seems to be about the theme. It always seems to make it just nats whisker worse by tightening it all in the full torque. Work that one out.
So as usual, I'll put some more information in the description, and I'll go through the measurements that were checked and give some explanation. The only one that really made any marked difference between the two was the first test, and I think that was probably because I didn't actually do it up as hand tight as I normally do. But I'll go for those measurements and you can draw your own conclusions on these. As far as the actual measurements that we've actually got written down or checked go, my equipment's not calibrated and any angles will change those measurements, so they're all subjective. But the whole point here is actually to see the difference in run out. But anyway, you can come to your own conclusions, but it's £130 feet for an ER-40. So with that, I'm going to leave you. Put something down in the comment if you want to say anything. If you've got any other ideas of anything to test. I'm going to do a run out test on a few other bits and pieces. Again, everything's subjective, but let me know what you think anyway. Cheers for your time. I'll see you soon. Ta-da.